In this video, I'm going to be upgrading the CPU, RAM, and technically even the video card in this late 2014 Apple Mac Mini. Now, as you can see here, this is a base model Mac Mini, 2014 model with the 1.4 GHz Intel Core i5 CPU and 4 GB of soldered 1600 MHz DDR3 memory. Now, in this video, I'm going to be replacing both the CPU and the soldered-on memory with the following. So right here, I've got a 2014 MacBook Pro 13-inch logic board, which has the 3 GHz Intel Core i7 CPU on it. And right here, I've got a set of DDR3, LPDDR3 rather, chips right here, which is what this Mac Mini uses. Now, these are LPDDR3 chips, which means that the chips themselves are much higher density than standard DDR3 like you'd find on this MacBook logic board. As you can see, there's 16 chips on this board, but of course the Mac Mini has 4 chips rather, but they're high enough density that each chip itself is 4 GB, which would make a total of 16 GB of memory to be installed into this machine. Now, like I said, I'm going to be taking the CPU off of this board. Of course, we can't use the RAM from this board, but it only has 8 gigs anyway. But this board is dead. We'll be using this CPU, reballing it, installing it on this board, and then this memory will be installed on the board as well. Now, one thing I did mention is that we are also going to be upgrading the video card in this, and while that's not technically the case, because this has integrated graphics, of course, the CPU that's on this board, the 3 GHz i7, actually has Iris, or Intel Iris video, integrated into it, whereas the CPU that's in this machine right now has only Intel HD Graphics 5000. Now, I'm not really sure that there's much benefit in that upgrade, but it just comes with the CPU upgrade, so I'll take it. So with that, the first thing I want to do here before we start taking the machine apart is I'm going to go ahead and open up Geekbench, and we'll run a benchmark in this machine. Go ahead and open a copy of Geekbench 5 I've got installed here. And as you can see, it gives us a little bit better info of the specs of the machine. So you can see it has an Intel Core i5 4260U running at 1.4 GHz, of course, and of course that same 4 GB of installed system memory. So with that, I'll go ahead and begin the benchmarks. So this will take quite some time to complete, of course, so once it's complete, I'll go ahead and resume the video and show you the results. Alright, so as you can see here, the Geekbench has completed successfully, and you can see we have received a single-core score of 659 and a multi-core score of 1267. So go ahead and scroll down here, we can see a little bit more about it. There's usual things there for Geekbench. Of course, I will put a link to this as well as the final result that we take later in the video description. But for now, that has been all the tests we need to do before we perform the upgrade. So now I'll go ahead and shut the machine down, take it apart, and then we can begin the process of upgrading the installed memory. So I'm going to do the memory first and then the CPU once I verify that works as intended. So go ahead and shut the machine down and get it taken apart. Alright, so as you can see here, I've gotten the machine completely taken apart. I've already removed the board and put it on the board preheater here. So of course the first thing we need to do, before we do anything else, is just to remove the little pieces of adhesive or edge bonding around the edge of each chip. So go ahead and just use a pair of tweezers to do so. And I do already have it on the board preheater here, so that way everything is nice and hot, so I can easily remove these pieces of adhesive. Alright, and now that all of the adhesive has been removed, we can go ahead and begin removing the chips. So the first thing we need to do, of course, is apply some flux to each one. Just like so. And then I'll go ahead and use the hot air to remove each chip. And I'm going to set the hot air to around 300 degrees, which should be good enough. Alright, so as you can see there, we have now successfully removed all 4 chips. So now we're ready to begin cleaning the pads with some solder, with the soldering iron and some solder wick. Alright, so with that already here, we'll just go ahead and apply just a little bit more flux to each pad. Just like so. And then we'll take the iron and first start by applying some fresh leaded solder to each pad. Alright, and now with that done, we'll just take the solder wick and remove all the residual solder. Alright, so now with all the residual solder removed, we can just go ahead and clean up all the burnt flux, just using rubbing alcohol and a paper towel. Alright, and that's about as clean as it needs to be right there. So now we can go ahead and prepare the new chips to be soldered onto the board. So in order to do that, just go ahead and remove the board from the board preheater here and get our new chips all laid out onto the board, or onto the board preheater. So as you can see, we've got all 4 new chips right there. So what we're going to want to do with these is just apply some flux to each one and then heat them so the flux flows into place. We just want a little bit of flux on each one. And once the flux has been applied, we'll go ahead and take each one and heat it to flow the flux onto every ball. Alright, and now that we've gotten flux applied to each chip, we'll go ahead and take the chips aside and then put the board back on the preheater. Alright, and with the board back on the board preheater heating up once again, we'll go ahead and take each chip and apply it into position on each set of pads. Alright, so all the chips look to be in their general location. I'm going to go ahead and verify that just a little bit off camera to make 100% sure that they're aligned. And I'm just going to do that based on a picture I took of when the original chips were still on there. And then I'll be able to use the hot air to solder each chip into position. Alright, so each chip looks to be aligned in its general location. So now we'll just go ahead and turn the hot air on and start soldering them on. Alright, so all the chips look to be soldered on successfully, so we'll go ahead and let the board cool down and then take a closer look at them. Alright, so as you can see, all the chips have been soldered on successfully. So if we go ahead and take a look at them from the side here, you should be able to see the solder balls under there just a little bit. I don't know if you really can because that shield there is in the way. But what you want to check is just to make sure all the chips look uniform on all four corners, and they do indeed in the case of this board. Then you want to make sure they line up as you'd expect them to. Should all be even. And as you can see, they are. So it looks like all the chips have been soldered on successfully without issue. So now we'll begin the process of setting the SPD info to detect all 16 gigabytes of installed system memory. Now, if you've seen my previous videos about the MacBook Air upgrades I've done, you'll know that in order to do that, we've modified the SPD data inside the system's ROM in order to detect the newly installed memory. However, in the case of this machine actually came from the factory with a 16 gigabyte configuration, which means all we need to do is set some strapping configuration resistors on the motherboard. So I'll go ahead and pull up a document here, or a picture that somebody has made showing exactly the different positions of SPD strapping resistors that can be set for different memory configurations. And then from there we can determine the correct configuration to set on this board for 16 gigabytes of memory. So with that, I'll go ahead and get that open and show you exactly what we're going to change. Alright, so as you can see here, I've pulled up the diagram for 16 gigabyte LPDA memory configuration, which is exactly what we have on this board. And you can see the necessary resistors that need to be set or not set right here. Now, I will put a link to the post, this is on Mac Rumors, for this specific post in the video description if you would like to take a look at this yourself. But in the case of this board, I went ahead and checked all these, and it looks like we only actually have to change one configuration. So coming over to the board here, I'll go ahead and show you exactly what we're going to be changing right here. So as you can see, here are the resistors that are shown in that diagram, and everything is set correctly here except this one resistor right here. So this guy, or actually it would be this one right here, needs to be moved down to those pads right there. So I'll just heat this one, take it from here, put it on these pads, and then I verified that the rest of them are already set in their correct locations. So this one must just be setting LPDA 4 gig to LPDA 8 gig, or 16 gig rather, which would make sense. And if there's any I missed, I'll be sure to set those as well, but based on what I see here, it looks like everything is already set correctly except for that one resistor. So I'm going to go ahead and get the camera back in the tripod once again, and we'll go ahead and swap that resistor position. Alright, so now with the board prepared here, we'll go ahead and turn on the board preheater, and we'll begin the process of moving that small resistor. Alright, so the first thing I want to do, of course, is just apply some flux to the pads that we're going to be soldering on here. Just put some right there. And then once everything gets up to temperature here, we'll just take that one resistor, locate it right there, and move it to the lower pads as I showed you earlier. Alright, so our resistor has been successfully swapped there. So now we'll just go ahead and let the board cool down. And once it's cooled down completely, we can go ahead and reassemble the machine partially, test it, and see if it works. Alright, so as you can see here, I've gotten the machine kind of reassembled enough to power it on and give it a test. So let's go ahead and plug it in and see what it does. Just like a MacBook Air, these things have to post like 3 times before they actually turn on. So hopefully it'll power on in just a second here. And there we go. As you can see, it chimed. So let's let it boot into macOS and make sure it detects all the installed memory. And as you can see, it is booting up here. So this is a standard hard drive at the moment. I will be upgrading this to an SSD, of course. But for now, I'm just going to go ahead and pause the video here, let it boot up, and see what it detects. Alright, so the machine has finished booting up. I've gone ahead and opened the About This Mac menu here, and check it out. There it is. You can see it detects 16 gigabytes of installed system memory. So let's go ahead into System Report here and just check it out one more time in the memory section here. So yep, as you can see, it detects two 8GB modules installed, and everything looks to be correct. So that has been the successful upgrade of the memory to 8GB. Now it's time to turn our attention to the CPU and start working on that. So in order to do that, before I do anything else, I'm just going to take the CPU off of this board, get it reballed, and prepared to install onto this board. So with that, I'll go ahead and get this in the board preheater and prepare to remove the CPU. Alright, so as you can see here, the target or our donor board here is up on the board preheater, all warmed up and ready to go here. So the first thing we need to do, of course, is to remove this black piece of tape that's over the edges of the CPU. So we'll go ahead and just pull that off here. And since the CPU is nice and warm from the board preheater, this just comes right off. And then the next thing we need to do, of course, is we need to remove the edge bonding from each corner of the CPU. As you can see, this is a little bit more stubborn than the ones for the RAM on the MacBook, or the Mac Mini logic board. Okay, so all that's off successfully. So now we're ready to apply some flux and begin desoldering the chip. And now we are ready to remove the chip. Now one thing I want to make you aware of with these specific chips, these Intel U series CPUs, they are very sensitive to heat. So if you heat them too much, they will warp and become pretty much unusable at that point. They do tend to warp anyway, even if you heat them properly, but they warp just a tiny bit, which you can compensate with a little bit of larger solder ball, and I'll show you that when we reball the chip, which is what I always do with these particular chips. So with that, I'm going to go ahead and put the hot air nozzle on, and the bottom heat here I'm going to heat up to about 175 degrees Celsius, and the top heat I'm going to heat it to around 280. I don't really want to go any higher than 280 for one of these, so hopefully that should suffice in getting it off. So now I'll just go ahead and align the hot air nozzle over the chip like so. And make sure that's properly aligned, and of course I'll use a flashlight to verify. Lower it down just a little bit more. You just don't want it to touch anything on the board. Alright, and that looks about good there. So now we'll go ahead and turn the hot air on and remove the chip. Alright, so the chip is now ready to come off the board. So go ahead and remove the hot air and pick up the chip. So I wasn't quite ready there. We'll try it one more time here in a second. There we go. Now we've got our chip off the board. So now we can go ahead and let everything cool down. And now that once everything cools down, we can begin the process of reballing our donor CPU. Alright, so in order to begin the reballing process, the first thing we need to do is remove all the residual solder using the soldering iron and of course some solder wick. But before we do that, I'm just going to apply some fresh solder, some leaded solder, just to make that a little bit easier. Alright, and now that all the residual solder is removed, we are ready to begin the process of reballing the chip. So in order to do that, the first thing I need to do is clean all of the old flux off the chip, and then we're going to apply just a thin, very thin layer of new flux to allow the balls to flow properly once they're on there. So I'm going to go ahead and clean off the chip right now. Alright, and as you can see here, the chip is now nice and clean, and it is now ready to be reballed. So I'll go ahead and get my stencil set up here and get this ready to go, and we'll begin reballing the chip. Alright, so I'm now ready to begin the process of reballing the CPU. So I've actually got my stencil right here. You can see that's what it looks like. And I've also got this little jig here that makes it a lot easier to align the chip and align the stencil and all that stuff. So I'll be using this. And I've also got a jar of 0.45 millimeter solder balls. These CPUs, according to the stencil, call for 0.4 millimeter balls. So I'm going to use some slightly bigger balls just to make sure that the chip seats fully down on the board once we solder it back on. As I mentioned, just to compensate for that warping that they do. And this one is indeed warped just a little bit. I don't know if you'll be able to really make that out. Let's see if I can focus in on it. Yeah, you can see it is warped just a little bit. This is pretty normal for these. Whenever you take them off a board, they always do it. So like I said, in order to compensate for that, if you use some larger solder balls, enough of the solder balls making contact will have enough force to actually unbend the chip and solder it fully to the board. So that's how that works. So with that, the first thing we need to do, of course, is just apply a small bit of flux to the chip itself before we reball it. So I'll go ahead and do that here. Now we don't want too much here because we do have to wipe most of it off because we don't want much on the chip because it will make the balls stick to it too much. But if you just have a small little bit, that is all you need. So go ahead and turn the hot air on here, and we'll just use the hot air to heat the flux and flow it around the chip. Okay, with the flux flowing around the chip here, probably be a little warm. You just want to take it and wipe away all the excess, or just basically as much as you can, just so there's a very, very thin layer of flux on the chip. The edge is good. And there we go. You can see there's just a shiny little sheen on it, or a sheen on it, I guess, with the flux, and that's exactly what you want. So now I'm going to go ahead and move the optical drive here out of the way, and we'll align the chip into the stencil holder. So we'll take our stencil holder right here, just put the chip in the little indent right in the middle. Actually, let me clean that out real quick. You want to make sure it's fully seated in there. There might be a little bit of that edge bonding still stuck to the edge of it, which is why it's not fully going down. You do want to make sure this is completely clean as well. Alright, now it should fit in here. Just like so. And with that now in there, we can take our stencil and align it accordingly. Just like so. And then you take it and put it on this magnet, and that will hold the stencil down. Alright, so now that stencil is ready to go. So now I'll begin the process of reballing the chip. Alright, so now that we've gotten the stencil all set up here, we can begin the process of reballing the chip. So we'll just take our solder balls, which are in this little jar right here, and just sprinkle them on top of the chip. Alright, and that's about good there. So then what you want to do is kind of just shake them around And if you get lucky, you'll get all of them in the holes, but most of the time that will not happen. You can kind of move around with your finger a little bit as well. Alright, and that looks to be about as much as we can do there. That's almost pretty much perfect, actually. But luckily with this stencil kit, you can actually empty the excess balls back into the container using this little spout right here. So we'll go ahead and do that here. Sometimes it's a little difficult. Alright, so there are still some on there, but we do want to leave a little bit on there because we will need to manually put some in some of the holes using some tweezers here. So I'm going to go ahead and prepare my tweezers by cleaning them off, because any flux or anything on them will make it almost impossible for the balls not to get stuck to them. Alright, so I've gone ahead and cleaned my tweezers pretty well here, so now we'll just take the solder balls that are excess here and place them into holes where there is no solder ball. Alright, and that is looking pretty good there. There's no excess solder balls on top of the stencil, and every single hole has a ball in it. So now we'll turn the hot air back on once again, and we'll start heating the stencil with the solder balls on it, of course, and that will melt the balls and attach them to their respective pads. Now, one thing I should mention, with this specific type of CPU and this specific type of stencil, you cannot use solder paste on this because it doesn't sit completely flush with the chip, and if you try to use solder paste, it's just going to flow all under the stencil and just make a gigantic mess. So with stencils like this, especially with the CPUs with the capacitors in the middle like this one, you cannot use solder paste to reball these. So with that, I'll go ahead and start heating these solder balls into position. And you want to hold down the middle here because this part likes to come up, and it'll cause the balls to be able to move around underneath the stencil. So with that held down, we can just go ahead and start heating. Alright, so now with all the balls seemingly melted into position, we're just going to let it cool down while holding the middle just a little bit. Once you've confirmed all the balls have seated in and are now dry, you can go ahead and apply a little bit more flux all around the chip. Just like so. And what this is going to do is this is going to ensure all the balls fully seat properly, and the flux will help move them into position. So go ahead and press on the center one more time. Verify that none of your balls have moved. You can see that one of them has right there, so we'll just get that back in its hole. And we'll start heating once again. And at this point, you probably don't need to hold the center. I still will just to make 100% sure here. Okay, so I'm going to stop heating once again, and we're almost done here. I just see one problem that we need to fix before we go further, and that is we've got 3 balls right over here that did not fully seat down in their holes. So all you got to do to fix this is just get it up to temperature, and then once they're molten, you just tap on them with your tweezers and they'll go right down in their hole. Back through and heat them once again. And now that everything looks to be fully molten, we'll just let it cool down just for a little bit. You don't want to let it cool down too much. And then we'll just go ahead and remove the stencil. just like so. And once you've removed the chip from the stencil, you'll want to go over it one more time with the hot air and heat the balls till they're molten one last time with no stencil on the chip. So I had one little issue right there. You can see that 2 of the balls merged, or actually about 3 of them did. I don't know what happened there. But I'll go have to wick all those off and just manually apply a few more balls to fix that. So I'll just do that off camera, get the chip all ready to go, and then we'll begin the process of getting it prepped to install on the new board. Alright, so as you can see, I have finally finished reballing the chip. Those balls on this side were kind of a pain, the ones that were not sitting down properly and that merged. But as you can see there, they're all even now. They all look good, and everything looks as I expect it to. So we'll take a look at the side. You can see the balls are there. You can see the chip is kind of warped right there. Like I said, that shouldn't be too big of a deal. So now we'll go ahead and get the Mac Mini board on the board preheater and begin to remove the CPU on that. So I'll go ahead and get the camera and the tripod once again and begin removing its CPU. Alright, so as you can see here, I've gone ahead and got the Mac Mini logic board up on the board preheater here. So now we can just do basically the same exact thing we did before with the other CPU and just remove the edge bonding. As you can see, that comes off much easier than the MacBook Pro edge bonding. And with that, we are now ready to begin adding flux and then removing the chip. Alright, the chip's ready to come off, so we'll go ahead and remove it. Almost. Now it's ready. Alright, so go ahead and turn the hot air off, let it cool down, and from here we'll just go ahead and start preparing the board to install the new chip. Alright, so now with all the solder removed, we can go ahead and clean off the old flux. And now we're ready to install the new chip. So the first thing I'm going to do is just apply a little bit of fresh flux. And then from that, we'll just wipe away a little bit of excess. Just like so. And then we will take our new CPU and align it onto the board. So of course there is no silkscreen outline on these boards, so that makes it quite a bit more difficult to get these things aligned. Okay, and that's probably pretty close right there. I did take a picture of it before I removed it, so I'm going to go ahead and reference that off camera and get it fully aligned, and then from there we can begin soldering it down to the board. Alright, well, interestingly enough, it looks like I got it pretty much perfect on my first attempt there. So now we're ready to just get the board up to temperature again and start heating the chip and soldering it on. Alright, so the chip looks to be in good position now, so we'll go ahead and solder it on. Alright, so that looks to be fully soldered on already. Because it's a leaded solder, it solders at much lower temperature, so it's much quicker. So we'll go ahead and turn the hot air off, turn the board preheater off, and let the board cool down. And then once everything's cooled down, I'll go ahead and show you a close-up and we'll check it out, make sure everything looks good, and then we'll give it a test. Alright, so as you can see here, the chip has been soldered on successfully. So if we go ahead and take a look at it from the side here, hopefully we'll be able to see the solder balls under there. Yeah, you can kind of see them right there. So you can see they look nice and uniform, which is exactly what you want to see. And also, if you take a look straight on at the chip here, you might be able to make out the fact that the chip is actually no longer warped. It actually straightened itself back out, just as I said it would, and it looks perfect. All the balls along each side of the chip look to be fully connected to the board, and like I said, the chip is no longer warped at all. So that's perfect. It's exactly what I want to see. Now there's one step that I actually forgot about, and that is because along with the CPU on these models, these U-series Intel platforms, there's also the PCH on the same chipset. So the PCH is right here, the CPU and integrated video is in this die right here, and on any modern Intel platform, whenever you change the PCH, you also need to clean the ME region because it's paired to that specific PCH. So in the case of this machine, we'll just need to dump its SPI ROM, which is located right here. And luckily, since this is a TSOP SPI ROM, I can simply use my TSOP clip onto it, and dump it that way. I might have to inject some extra voltage, which I've had to do before on some of these, but it should dump no problem externally or in circuit like this. So with that, I'll get all that set up and show you exactly how that's done. Alright, so as you can see here, I do have my TSOP clip on there, and I did end up having to inject some voltage into it, so this does look a little bit janky, but I just have the ground wire and the VCC wire connected to a power supply here, set to 3.3 volts as you can see, and I've got that connected to an XGAQ TL866 programmer, and then from there I can go ahead and read the chip. So the first thing we're going to do is just turn on the output of the power supply. You can see the board is pulling 0.007 amps on the 3.3 volt rail, and with that done we can go ahead and select read and read the chip. So we'll just wait till the read finishes here. Okay, and the read has completed successfully. So let's go ahead and check it out here, make sure everything looks good. Yeah, we've got data all the way down to the very end of the ROM. So I'm going to just read it one more time just to make 100% sure, and then from there we can go ahead and save it and open it and begin the process of cleaning the ME region. Alright, so I read it one more time, verified it was correct once again, and now have saved the file as mini71.bin right there. So the next thing we need to do is download a copy of a firmware update for this specific model. So I've already done that. There is a GitHub repo here with all the Apple EFI firmware updates. I just downloaded the latest one from there, and from there we need to open that in the UEFI tool. So as you can see, there's the download right there. Let's go ahead and open the UEFI tool real quick. We'll of course need to use the old engine version. So here we go. Go ahead and open the image file we just downloaded. That'll of course be the firmware update for the Mac, or well in that case the MacBook Air 7,1. I guess it's both the same. Let's see. No, that's actually a different firmware update. That's what I did before. There's also a Mac Mini one in there. Whoops, my bad. That definitely would not work. Oh, it's looking for only those. There it is, Mac Mini. Alright, so I've gone ahead and opened the Mac Mini one, as you can see up there. So we need to find the ME region in here. I forget exactly where it is. Alright, so I found for this specific type of extraction here, the best tool to use is actually the NE or new engine version of UEFI tool, and because that gives you a little bit more info on the GUIDs there. And if you see ME region update volume, and then the raw section in there, that should be the ME region. So we'll go ahead and extract body. We'll go ahead and save that to the desktop as ME Mini71 clean .bin. And now that's saved, so let's go ahead and open it in a hex editor here and see what that looks like. So yes, this does indeed look like the ME region, and we can verify that with the other tool we're going to use for this. So if we get out of all that, we need to go to the Intel ME system firmware system tools here. There we go. So you need the flash image tool for the later chipsets, so the Broadwell and Haswell chipsets. So with that tool open, now what we need to do is go ahead and open the dump we made of the SPI ROM for the machine. And actually that's not how we're going to do that here. We're just going to go ahead and minimize everything here and just drag the dump we took of the machine onto this window here. And that's actually going to extract everything. So we'll go ahead and save this on the desktop as mini71.xml, and that'll just save it as a file for this utility, which we will need later. So now we go ahead and close it. Go back into the file. You can see it made a folder for that ROM. Go to decomp, and you can see ME region right here. So we can verify that our ME region extraction was correct based on the size as well as the content. We'll check in just a second. So you can see it's 1.10 megs there, and this one is a little bit bigger at 1.54, so maybe I need to extract that differently. Alright, so I went ahead and opened both in the hex editor here. So this is the one that I extracted from the ROM itself, the SPI ROM dump, and then this is the clean section. So that looks pretty good to me. I think that'll be correct. They are exactly the same. It's just the size is slightly different. I think the tool will take that into account though. So with that, we're going to go ahead and copy the clean ME region right there into this directory, the decomp directory for the ROM we extracted. Let's go ahead and paste that in here. Delete ME region.bin. Rename this to ME region.bin. Just like that, just so it took its place. And you can see there's the original. Go ahead and get rid of that. And now we can go back and open the tool again. Go ahead and open the XML we saved earlier for the Mini 7,1. And now do build image. Select yes. Select yes. And now that has completed. So now if you go back into Mini 7,1, if you go to build outimage.bin, that should be our newly cleaned ROM. You can see it was just created now. So we can open that in the EEPROM programming tool and simply flash this onto the chip. So go ahead and do that here. Select load, go to the folder here for the ME system tools. Load that image in. As you can see, it looks the same, and select program. So this will take quite a bit to complete, as you can see here, so I'll go ahead and wait it out. Alright, so now that that is complete, we can go ahead and disconnect everything, hook the board up back in the machine, and give it a test. Alright, so as you can see here, I've got the machine put together once again. So now we'll go ahead and plug it in and see if it boots. So it's doing that usual thing again. And it shined. And we have video. And let's go ahead and boot it up and see what it looks like. And it booted successfully, so that's good. Alright, let's go ahead and check out about this Mac. And look at that, there it is. 3 GHz dual core, Intel Core i7 of course, 16 gigabytes of memory installed, and we also have that added bonus of Intel Iris graphics instead of Intel HD Graphics 5000. So let's go ahead and check the system report. And yeah, everything looks good here. Memory, everything looks the same there again. So yeah, there it is. A fully upgraded late 2014 Mac Mini, which went from a complete base model with 4 gigs of RAM and a 1.4 gigahertz i7 or i5 to a 3 gigahertz i7 with 16 gigs of RAM. So, of course, our last step here is to run Geekbench and see what our performance improvement looks like. So I'm going to get this thing connected to the internet. I don't have the Wi-Fi card in it right now. And then we'll go ahead and run the Geekbench. Alright, so I've gone ahead and gotten an Ethernet cable plugged into it. So let's go ahead and open up Geekbench. And look at that. Look at those specs. We've now got the Intel Core i7 4578U at 3 gigahertz and 16 gigs of installed memory. So let's go ahead and run the benchmark. So like before, this will take quite some time to complete. I'll go ahead and pause the video here and resume it once the results are available. Alright, so the Geekbench results are here. The benchmark, of course, did complete successfully. So here are the results we've received. So now we have a single core score of 864 and a multi-core score of 1802. Now, this is a little not as much of an improvement as I was expecting to see, but I do have the other results right here, which we can compare against, and you can see that on these, on this one, we originally had a 659 and a 1267. So it is a little bit of an improvement. I think the scale of improvement on Geekbench 5 is a little bit less than older versions, so it doesn't look like it's as much of an improvement as it actually is. But let's just go down here and see if there's anything that looks relevant at all. So yeah, I mean, it definitely improved quite a bit there, so there is some improvement with this. The main improvement, though, of course, is the RAM upgrade. I just kind of did the CPU upgrade just for fun more than anything, just to see if it was even possible. But yeah, as you can see, it is. So there is the successful upgrade of a base model 2014 Mac Mini to a 3 gigahertz Intel Core i7 with Intel Iris graphics, along with 16 gigabytes of system memory. So I hope you enjoyed this video.